In this video, we're going to determine the magnitude and direction of a vector sum. So let's say that we have the sum of a plus b vectors, where we have vector a is 6, 8, and we have vector b is 3, 4. What we're going to do is you're just going to add these based off their components. So you'd add the x component plus the x component and the y component plus the y component, giving us 9, 12. Now, how would we find the magnitude? Magnitude is going to be the vector sum. This is going to be the vector sum. But to find the magnitude of the vector sum, we're going to take the components and we're going to use the Pythagorean theorem on them. So it's going to be x squared plus y squared. Because this is the x and this is the y, you can imagine this as a triangle. Like, you have 9, and then you have a right triangle that's 12. And then you're trying to find what this radius is, almost. And you're just going to use your Pythagorean theorem because those are your legs. So you're going to have 9 squared plus 12 squared is 81 plus 144, which is the root of 225, which is 15 as your magnitude. But we also have to find our direction, which we're going to get by using tangent, which is the function that relates our y and x to each other, which is the angle we're going to have here. We want to find that direction that the vector is pointing from the positive x-axis. So we can substitute in our y and x. That's equal to tan theta. But we don't want that. We want to get that theta by itself. So we're going to take the inverse of both sides. And then we can clearly see that theta is equal to that tan negative 1 of 4 over 3, which is going to be approximately 53.13 degrees. Since we know that 9, 12, if we draw out the rest of our coordinate system here, this is going to be in Q1. So that means the direction of our angle is just 53.13. We don't have to adjust. And you have to remember this because tangent has a restricted range, which is going to be when we are in this part of the unit circle. So if your angle output from your inverse tan, this is for tan inverse, by the way, is an angle in the left-hand side of the circle, you must add 180 degrees to flip to the other side. Because those values don't work for tan. Now, our magnitude we got is 15. Our direction is 53.13 degrees. Let's do this again. So we have a vector with a magnitude of 6 and a direction of 0 degrees. That's your mag. That's your direction. We want to find, we know that vector v, this is going to be vector u. So vector v is going to have a magnitude of 8 and a direction of 180 degrees. So we want to find u plus v. So what we're going to do is we can convert these into component form because they're conveniently on angles that we know, 0 degrees and 180. So we have to think, if we have a direction of 0 degrees, that means that our vector is going to point to the right. So it's going to be this, and it's going to be 6 long. And for this, if we have a vector pointing in 180 degrees, it's going to be this way, and that vector is going to be 8 long. So we can write these as 6 in the horizontal direction and 0 in the vertical direction. And this one is going to be negative 8 in the horizontal direction and 0 in the vertical direction. Now, all we're going to do is we're going to add the vectors. We'll add this component based wise, where you add the x components and you add the y components. You never add the x components to the y components. Now onto our magnitude. Our resultant vector of adding u and v will be equal to negative 2 squared plus 0 squared. And this formula is equal to 2, and again, this is from x squared plus y squared of our component form, where this is our x and this is our y. Now we have to find our direction. So we know that because our negative 2, 0, we have negative 2, 0, right? So we see that that's going to be on 0 degrees, but then we're going to go to the left side. So that means you're over here. Therefore, you have a direction that is going to be 180 degrees from the positive x-axis. So 180 degrees is your direction. Now, let's say that h has a magnitude of 5, direction of 0 degrees. And let's say k has a magnitude of 12 and a direction of 180 degrees. And we want to find the magnitude and direction of h plus k. How we're going to do this is we can interpret each vector. If we have h, we know that that's going to be like this. You're going to have in 0 degrees, that means you're going to the right, and it's going to be 5 long. Now for this, we're going to go in 180 degrees direction, and it's going to go left. So that's going to be a length of 12. And if we had to write these in component form, this would be 5, 0. This would be negative 12, 0. If you want to add these vectors, you're going to have 5, 0 plus negative 12, 0, which gives us 5 minus 12, 0 plus 0, and negative 7, 0. Now we have to find the magnitude using the process we did earlier. So we're going to take our x and y, negative 7 squared plus 0 squared, and that's equal to the root of 49, which is going to be 7, which is the magnitude of our resultant vector. Now we also have to find the direction. So we know that if we have this graph, we know that we're at 0 degrees, but we're going to go to the left because we have a negative. So that's going to be a measurement of 180 degrees from the positive x-axis for theta. Now, let's say that vector c has a magnitude of 10, 90 degrees, and vector d has a magnitude of 10 in 0 degrees direction. We want to find c plus d. What we're going to do is we can see that this is going to be 10 magnitude in the direction of 90 degrees. So that is 90 degrees. And here, we're going to have in 0 degrees 10 as well. So theta is equal to 0. So as components, this is 0, 10, because we have no x movement, and this is 10, 0. And really, the reason why you use sine and cosine, later we'll do this, for your component form is when you're not on an axis. So that's why you have to use sine theta and cosine theta to spit out a result, or to spit out an angle, because here we're conveniently on 90 degrees and 0 degrees, so you can see that there would be no movement in that x and y direction. But when you have to find at an angle, you're going to have to find that x and y direction. So c plus d is going to be 0, 10, plus 10, 0, 10, 10. Now to find the magnitude, we have c plus d, which is going to be equal to the root of x squared plus y squared, which is 10 squared plus 10 squared, which is 100 plus 100, and that's square root of a 200, aka 10 root 2, which you can see 20 times 10. We can take out a 5 here too, and we have a 2. We can split this up into 2 and 10, and we can split this up into 5 and 2, so we have this, and we have this. So, let's see here, 5 and 2. Okay, I split this one up twice. Just 110 here. So you see that you have 1, 2 left over. So that's why you have your 2 left over, and you have 5 times 2 out here. Now, we can find the direction where we have tan theta is equal to y over x. 10 over 10 is equal to 1. Theta will be equal to 45 degrees because at that point you have the coordinates root 2 over root 2, which are equal to 1, where that's your y and that's your x, right? So your direction is 45 degrees. And we also can check this because we know if we have 10, 10, right? We would go this way, 10, and we would go this way, 10 as well. And then we would have our vector, that would be this. And the magnitude of this vector would be 2. Now, that is our magnitude and our direction. Or the magnitude of this would be 10 to the root 2. So let's do another example. This is question 4. Let's say we have two vectors where we have f, 4, and then 45 degrees. And then we have g, which is going to be 80 degrees, and we want to find the magnitude and direction. So what we're going to have to do here is, since we have 45 degrees, we need to know that when you have component form, when you have a vector with a magnitude that is going to be r, and your direction is theta, you're going to have our cosine of theta, our sine of theta. And that's going to be for both of these. Just write that once, actually. So in order for us to find vector f, we're going to have to do 4 cosine 45 degrees and 4 sine 45 degrees. Here we are going to have we're going to have 8 cosine 0 degrees, and then we're going to have 8 sine 0 degrees. So if you add these, this is going to give you your resultant vector. So we can simplify this. First, we have 4. Now, what is cosine of 45 degrees? Let's first map out where we have 45 degrees. When we're at 45 degrees, we're going to have root 2 over 2. So that's going to give us root 2 over 2. And we're going to have 4 root 2 over 2. So this is going to give us 2 root 2, 2 root 2. After that cancels out and it's just a 2. Now, what about for vector g? So actually, let's keep adding them here. Show all of our work, step at a time. For vector g, we know that we have 8 cosine 0 degrees. So if you're at cosine 0 degrees, that's going to mean you're at a value of 1, because you're going to have 1, 0 degrees. So here we're going to have 8 times 1, and we're going to have 8 times 1. So that just gives us 8 and 8. Now you just add vertically, and we are going to get 8 plus 2 root 2 and 2 root 2. This is actually 0 because that's x and y. So this is actually 8 times 0, so that would be 0. Now we have our values, and if you had this as a decimal, This would be 10.828, and this would be 2.828. Now, how do we find the magnitude? Well, the magnitude of f plus g, which is going to be the resultant vector, is still going to be our x squared plus y squared. Now, we'll just do that real quick. This will give you approximately 11.2. Now, we also have to find the direction. Now, this will be tan theta, which is y over x. We have 2.828 and 10.828. So this is going to be tan theta. Remember, you have to get the inverse on both sides. So theta will equal to approximately 14.7 degrees when you get the tan inverse of that right-hand side. So that's your direction. And this makes sense because this is going to be in the right quadrant 1, based off of our component form where we both have positive x values, positive x, positive y. Now let's do our next question. Let's say we have a vector w with a magnitude of 150 degrees and a vector x with a magnitude of 2.5, direction 330 degrees. And we want to find what that sum is. So we're going to convert these into component form. Okay, our sine of theta that's 330. Now, when you're at 150 degrees, you'll be here. So that means that you're going to be at a 30-degree angle reference. You'll be at root 3 over 2 1/2, but you're going to be at a negative x value. Now, what about when you're at 330 degrees? When you're at 330, that's 30 degrees. So you're at 330 degrees this way. So your value is going to be a 30 degrees reflection as well. 3 over 2 1/2. So you're going to have a positive x and a negative y. Now we can finish this. So this is going to give us, for w, we're going to have 9 times our x value, which is negative root 3 over 2. And we're going to have 9 times our y value 1/2. And then here you're going to have cosine, you're going to have 2.5 times your x value, root 3 over 2, and then 2.5 times your y value, negative 1/2. If you simplify this, this is going to be negative 9 root 3 over 2, and then 9 over 2. And then here we're going to have 2.5 root 3 over 2, and negative 2.5 over 2, which is going to be giving us a result of negative 13 root 3 over 4, 13 over 4. So now we have to find the magnitude of this. So that's w plus x, which is going to equal to the root of negative 13 root 3 over 4 squared plus 13 over 4 squared. Now, this would give us negative 13 squared would be 169, and you would have that root 3 cancel out, times 3 over 16. You'd have plus 169 plus 16, and that'd be the root of 676 over 16, which is 169 over 4, 13 over 2, which is 6.5, which is the magnitude. Now, for the direction, we are going to see that we have an x that is negative and a positive y. Therefore, if you have a negative x direction and a positive y, you're going to be in quadrant 2. So then, when we do our tan theta, we have 13 over 4, our y, over our x, 13 root 3 over 4. This will give us, canceling out that 13 and 4, we're going to have 1 over the root of 3. AKA, if we rationalize that, root 3 over 3. So then we know that that theta reference, when we have tan theta, we know we would have this when we have a theta reference of 30 degrees. And if that's our reference angle, and we know we're in quadrant 2, so that's going to be 30 degrees right there. That means that the standard position would be 150 degrees, because we would have 180 degrees minus 30 degrees equaling to 150 degrees. Let's say we have a vector k with a magnitude of 7.4 and a direction of 150 degrees. And let's say that we have a vector L with a magnitude of 3.8 and a direction of 330 degrees. So this is 7.4, and this is 7.4 sine. So 150 degrees, you're going to have negative root 3 over 2, 1/2. Now, you have 3.8 cosine. And this is root 3 over 2. This is 3.8. Negative 1/2. So here you're going to get 97.4 over times root 3 over 2, 3.7. And then this will give you negative 3.6. (1.8). Now for the magnitude, this is k plus L. Which will be 3.6. Direction is negative x, positive y. Q2. So that means that the ref would be 30 degrees. Since we're in Q2, you have to subtract it from 180. So actual is 150 degrees. Because here, you're just going to have an angle right here. 30. But you need that 150 from positive x. Now, so we have 3.6 and 240, and we have 8.5 and 30. .240 degrees is a reference from here. That's going to be 30 degrees. So that's going to be a reference of 60 degrees. So we would have then for 30 degrees, now we just add them. For a mag. And then when you find tan -1, that'll give you 11.6 degrees. We know that we have positive x, positive y. Therefore, we are in Q1, so that's the right direction. Say we have R. .210 is going to be That's going to give you root 3 over 2, 1/2, but negative y. So for our resultant vector, we'll get that after this. The magnitude is negative 3.5 plus negative 6 squared, 8.53. For our direction, we're going to have two negative values. We have a negative x and a negative y, placing us in quarter 3. So that means that for tan theta reference, we're going to have negative 6 over negative 3.5 times the root of 3, which will be 6 over 3.5 times root of 3, aka approximately 0.990 for tan theta. Now, if we get theta reference after taking the tan inverse, that's going to be approximately 44.5 degrees. But since we know that that reference angle is going to be just a reference angle and it has to be in the third quarter, we're going to have to add 180 degrees. 44.5 because we're in Q3, so that's going to be 224.5 degrees. That's going to be your direction. Now let's do some more examples. Let's say that we have to find E plus F. So this will be these values. I actually recommend that you just add it this way. So you can see that you'll have, actually, it doesn't really matter. So this is going to be when you have a negative x and a positive y, aka quadrant 2. So that means when we find theta ref, that's absolute value of y over x. So then you need to take the inverse tan. Now your final directional angle is going to be 180 degrees minus that 15.95 degrees. Approximately 164.05 degrees is going to be theta. And then our magnitude we'll get that'll be 7, approximately 1.04 for magnitude. So that is going to be a quadrant 2. That's your angle, that's your magnitude. And then we have our reference angle, which was this. So we found our different values. Your final angle is going to be different because it was in Q2. So when you were in Q2 or Q3, your theta reference is not equal to your theta final. And you must adjust. Now, let's do another problem. Let's find G plus H. So we can see we have a positive x and positive y. So we're going to be in Q1. Now let's find our reference angle. Tan theta is y over x. So then we have tan theta, but we want to find the inverse of that. So theta is equal to 20.56. Now your final theta is also going to be equal to 20.56 degrees because we are in Q1. What about our magnitude? This will be approximately 1.07. So that's for your magnitude. Let's do another example. Let's say we have vector m has a magnitude 9/8 at 315 degrees, and n has a magnitude of 4/3 at 150 degrees. Let's find the magnitude of adding m plus n. So, and also the direction. So for 315 degrees, that is going to be when you are 45 degrees away. And you're going to be at root 2 over 2, root 2 over 2. And then you're going to have a negative y. So that's your x and y. What about for 150 degrees? You have 150 degrees like this, and then you're going to have root 3 over 2, 1/2 with a negative x for your x and y. So this will give you your x value that's gonna be for cosine, so yeah. And then we're gonna have over here negative 2 root 3 over 3, and then 2 over 3. Now if you add these, this will give you negative 0.360, negative 0.128. Now let's find the magnitude. This is in Q3. Negative x, negative x. So we'll approximately give you 0.38 for magnitude. Now what about a reference? This will be negative 0.128 over negative 0.360 because we have negative values, right? And we're in Q2. And the reason is because when you have tangent, right? If you have 1 over 1 and negative 1 over 1, negative 1, it still gives you 1. So then how do you know what the y and the x is? There is some ambiguity there. So here, your theta reference would be approximately 20 degrees. You take the inverse tan. So then because we need to find our final, we're going to do 180 degrees plus 20 degrees, which will give us 200 degrees because we're in Q3. Now let's continue.